Hi, in the last few sessions, we had some understanding of machine learning concept. We talked about the supervised machine learning, unsupervised machine learning, and reinforcement learning. Now let's understand what actually a machine learning model is. Let's consider a simple example of supervised machine learning model where we are giving the training dataset as an input, where the output is tagged with each and every input. So we are giving the MCS as an input, and based on that we are expecting to have the throughput predictions on some very specific environment. Now, based on the training dataset, machine learning model will develop some kind of knowledge and build the relation that if the MCS is higher, then the throughput is also higher, and if MCS goes down, then the throughput also goes low. This machine learning model will be some mathematical function which can fit this relation of MCS and throughput, and that mathematical function will be used for predicting the throughput for the current MCS value in very specific environment. You can write it like throughput is some function f of MCS. This function f can be any mathematical formula like multiplication with some factors, power with some factor, addition or division of some constant, etc. The job of the training model is to develop that function which fits the relationship of MCS and throughput in any specific environment. Note that we are only considering a single function. However, one machine learning model will have multiple functions and dimensions for good prediction. That is why we are mentioning the very specific environment for our example, because we didn't consider the other dimensions and functions which affects the output, means throughput here. So here is a question for you. Can you name that which type of machine learning model you will use to develop this model for MCS and throughput? Please write in the comment section. Anyway, once you have that machine learning model with the function which has the relation between the MCS and throughput, then simply you can use that model where the system will get the MCS input and the model will predict the throughput. And as in future action, if the throughput not matches or very low in the current network, then you can have the another machine learning model which can predict the possible set of actions to improve that. Or even you can use a machine learning model which can take the action to improve the throughput in the live network based on the different combinations of parameters, radio conditions, user conditions, and many other factors. This way, how the machine learning models works together in the bigger ecosystem. Now let's talk about the basic building blocks in the machine learning development cycle. As we said that the input data is one of the most important ingredient in the machine learning, so the cycle starts from the data collection. If we consider the last example of MCS and throughput, then we will need a lot of good data which can help correlating the relationship between these two parameters. In network system, this data collection can be collected from the network OSS or from the drive test logs, etc., which can cover different aspects. So once you collected all the data, then the next step would be the data preparation. You may hear the general terms like data cleaning and cleansing, etc. So in this step, you filter out the irrelevant data from the collected data, filtering the data which is not complete, or removing the duplicacy in the data, etc. Or maybe you wanted to reformat the data or restructure the data as part of dimension reduction, which can reduce the complexity in the future steps, and you also can correlate the data in a better frame. Now the next step would be the selection of model, which method you should choose for the desired task, what algorithm would be a good fit for the requirement, etc. For the different use cases, you will need different approach, so right selection of model and algorithm is important. Once you finalize that what model or algorithm is a good fit for your specific needs, then you will start training the model by feeding it with the training dataset. For example, if your model is a linear regression model, then the x-axis will be your input and the corresponding y-axis will be your output. So this is important that the linear line is the best fit with the input data points in order to have a good prediction on your user input data. To get this optimal model which can best fit on the training dataset and which will be able to give a good prediction, you will need multiple iteration of training to your model. Now, once you get this good fit model, then you will need to test your model if that model is giving the right prediction on the new data, and for that we generally use the test dataset. This process we call evaluating the model. So you will give the test dataset as an input to the model, then you will get the predicted result which you will compare with the actual output to know the variation in the predicted output and the actual output. If the variation is high and you see the scope of further improvement, Then you will go through the more iteration of training the model or tuning the function parameters. And once you're confident that you have a good fit model, which is giving the right predictions on the test dataset and the user data as well, then you are ready with the machine learning model, which can be incorporated in the real life use cases and can perform the specific task for which it was developed. This model can be used individually for some specific tasks, or maybe this will act just like a small and individual component of a bigger system. That's how the machine learning systems works. In the next session, we will be talking about the ML functionalities and ML deployment in the OpenRAN. We will also talk about the concept of control loops in the OpenRAN. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to Learn and Grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.